Hello everyone, welcome to SAIMEDHA Koti Hyderabad. Myself Bhanu Prakash, Faculty of Electrical Engineering. In this session, I would like to discuss about another topic in the DC machine. The topic is operating principle of the DC motors. So, in this topic, what are the points we are going to be discuss? One is what are the basic requirement to produce the torque in the DC motor, and next one what is operating principle and how do we find out the direction of the force developed in the DC motor, and also what is the exactly mathematical equation of the force and torque. Okay, these points we will going to be discuss. The first one, what are the basic requirement, okay, to produce the torque in the DC motors. So, basic the requirement to produce the torque in the DC motors. Clear? The first requirement is a stationary magnetic field is required. The first one is the stationary magnetic field. So, this what is the meaning of the stationary magnetic field? So, that means the field, the magnetic field means the region around the magnet is known as a magnetic field. The stationary magnetic field, so that is the speed of this magnetic field. Okay, it is the speed of this magnetic field is equal to 0. So, this type of the magnetic field is known as the stationary magnetic field. And now we have a question, how do we develop the stationary magnetic field? So, it can be obtained by using the permanent magnets or electromagnets. For example, so we have there is a one pole, okay, this let us take one pole, it is a north pole, and other side, okay, it is the south pole, okay, north pole and the south pole. Always flux lines are passing from north pole to the south pole. So, this is the one magnet, one and other magnet. So, always flux lines, okay, this one is the flux lines passing from north pole to the south pole. So, it is like this, all the flux lines are passing from the north pole to south pole. So, this is the direction of the magnetic field. So, this I can say that field flux, okay, magnetic field flux. So, phi the phi is nothing but magnetic flux lines passing from north pole to the south pole. And another requirement to produce the torque, okay, these are the basic requirement to produce the torque in the DC motors. Okay, this T is nothing but the torque. So, a second requirement is the current carrying conductors, carrying conductors, clear? So, this is another requirement to produce the torque. Okay, what is the mean by torque here? The twisting moment of force about an axis. Suppose the torque equation, generally the torque is equal to force developed multiplied by the perpendicular distance. Okay, what is the perpendicular distance? Suppose force developed in the conductors, force developed, and perpendicular distance is the radius of armature core. Okay, this one is the radius of armature the core. Suppose armature is a cylindrical structure, okay, this one is the armature. Suppose this is the conductors are placed in the armature core. Suppose this radius, okay, it is known as, okay, this distance is known as a radius, and this length is a axial length of the conductors, and R is a radius of the armature core. So, torque developed in the motor, so that is equal to force the developed multiplied by the radius of armature core. The second requirement is a current carrying conductors. How do we develop this current carrying conductors? Suppose we have a conductors, okay, which is excited with the supply. Suppose this one the excited with the supply, then what will happen? So, current passes through the conductors, okay, this current here, some amount of the current passes through conductors. So, this is the current carrying conductors, some I amount of the current. Okay. Now the basic requirement to produce the torque in the DC motor, one is a stationary magnetic field. How do we produce the stationary magnetic field? By using the permanent magnets or electromagnets. So these permanent magnets are used for the small rating of the machine. Okay, these are used for the rating of machine. What is the meaning of the small rating? The rating of the machine is which is less than the 5 kilowatts. Okay, that is known as less than or equal to 5 kilowatts are known as a small rating, or more than that. So these electromagnets are used for the large rating of the machine. In general, so for large rating of the machine, the electromagnets are used to produce the stationary magnetic field, and permanent magnets are used to produce the stationary magnetic field. So in general, what is the meaning of stationary? Suppose we have a question, rotating magnetic field and stationary magnetic field. So this stationary magnetic field means speed of this magnetic field is equal to 0. And the second requirement is the current carrying conductors. That means conductor is excited with a supply or electrical source, so that what will happen, there is a closed path to flow the current, so current flows to the conductors. So these are the basic requirement to produce the torque. I repeat once again, what is the mean by torque? The twisting moment of force about an axis is called the torque. So a mathematical relation, so what is the torque here? The force developed by the conductors multiplied by radius of the armature core. So this armature core is a cylindrical structure, so that this is called the radius, and it is the axial length of the conductor or axial length of the armature core. Okay, got it? So now what is the operating principle? Okay, what is operating principle of the DC motor? The DC motor operates on the principle of the Lorentz force law. Okay, this what is the operating principle here? So that is the DC motor operates on the principle of the Lorentz force law. So what is the statement of this law? Okay, it is the Lorentz force law. So what is the statement of this Lorentz force law? So whenever a current carrying conductors, whenever a current carrying conductor is placed in the stationary magnetic field, the force experienced by that conductors. So that means we have a magnetic field, so north pole and south pole, so that flux lines are passing from north pole to the south pole. So there is a conductor which is, it is a stationary only, but excited with a supply, so that a current carrying conductor is placed in the stationary magnetic field. So what will happen, whenever a current carrying conductor is placed in the stationary magnetic field, the force experienced by that conductors. So this one is whenever, so whenever, what is the statement? Whenever a current carrying conductors, the carrying conductor, so this current carrying conductor is placed in stationary magnetic field. So this one is the stationary magnetic field, force experienced by that conductors, force experienced by that conductors. Clear my point? So this one is the statement of the Lorentz force law. So what is the operating principle? It operates, DC motor operates on the principle of Lorentz force law. It states that whenever a current carrying conductor is placed in the stationary magnetic field, the force experienced by that conductors. So this force mathematically, the force developed by the conductors. Okay, this force so developed by conductors, so that F is equal to, so this is the F is equal to the BIL, the sin theta. Okay, this one is the force developed by the conductor. So F is equal to BIL sin theta. So now we have a question, what is the mean by B and what is the current I, and this the L is the actual length of the conductors. Okay, this actual length means, so this is the axial length, but actual length of the conductor is, so this length of the conductor within the magnetic field. So this is the L. So length of the conductor within the magnetic field is known as the actual length of the conductors. Now where in this case the B is a flux density. So this one is the B. What is the mean by B here? The flux density. Okay, flux density. So that is a flux density means the flux by area. Okay, this area of the core. So area of the core. So flux density. So now therefore this here flux is the phi, and so area is A. So therefore this is the, what is the units here? Webers per meter square. Sometimes we have a question, what are the units of the flux density? Flux density is a Webers per meter square. Now I is a current passes to the conductor, current the in conductors. Okay, and what about the L? The L is the actual the length of the conductors, the length of the conductors, and theta is the angle made by the conductor with respect to the magnetic field. So now after rotation, so this one is the theta is the angle the made by, okay, this made by the conductor with respect to magnetic field. So this value is the theta. So what is the force developed current conductors? This equation also very important for competitive exams point of view. The F is equal to BIL sin theta. So now B is a flux density, I is the current in the conductor, L is the actual length of the conductors, and theta is the angle made by the conductor with respect to the magnetic field. Now we have a question that how do we find out? So how to find? There is a question here. So how to find the direction of the force? Find the direction of force developed, okay, in the conductors, okay. So direction of the force developed by the conductor can be obtained by using the left hand rule, okay, Fleming's left hand rule. So that is a Fleming's, okay, left hand rule. Okay, this one is the FLR. The FLR means, so that is a Fleming's, okay, Fleming's left hand, okay, left hand, okay, rule. So this is the force developed by the conductor can be obtained by using the Fleming's left hand rule. So this is also one of the possibility question. So how do we find out the direction of the force developed in the conductors? So this force developed in the conductor. So in general, what is the purpose of the FLR? Sometimes we have a question. So purpose of the FLR, okay, this FLR. So it is always used to find out the direction of the force developed in the conductor. So it is the always the use to find the direction of, okay, to find the direction of the force developed in the conductors, force developed in conductors. Clear my point? So this is the force FLR. So what is the exactly statement of the FLR? So how do we find out the statement? How do we define the statement of the FLR? Suppose forefinger, so this is the forefinger, center finger and thumb of the left hand. The here forefinger, center finger and thumb of the left hand are stretched in a perpendicular direction to the each other. So if forefinger indicates the flux direction and the center finger indicates the current direction, then thumb indicates the force developed by the conductor. Suppose we have a, so this forefinger, center finger and thumb of the left hand. So this one is the stretched in a perpendicular direction to the each other. So let us assume this is the forefinger, okay, and this one is the center finger and thumb of, okay, this is the thumb of the left hand, okay, this one is thumb of the left hand. So if forefinger indicates, okay, for example, so this one is a forefinger indicates the flux direction and center finger indicates the current direction. So then thumb indicates the force developed by the conductors. So this is a, okay, in this case, so these two are, okay, here these two are the known parameters, okay, it is a known, the parameters, direction known, this one, the known parameters. So now this one is a unknown, okay, we need to find out the this by using the these two known parameters. So it is an unknown parameter. So if we know the direction of the force in the magnetic, direction of the flux in the magnetic field, and if we know the direction of the current in the current which is which is passing through the conductors. So if we know these two, then we can find out the direction of the force developed by the conductors. Now actually sometimes we have a question. So force developed by the conductor in the DC motor can be obtained by using, so by using the FLR. Similarly, force developed by the conductor in the armature of the DC generators. So that means in the generator also motoring action takes place, the due to which the force developed in the armature of the DC motor. So that force direction also can be obtained by using FLR. So FRR is always used to find out the direction of induced EMF or direction of the induced current. But FLR, it is not the rule for the motor. So it is always used to find out the direction of the force developed in the conductor, whether it is a generator or motor. So in the generator also motoring action takes place. So due to which the force developed in the armature. So that force direction also can be obtained by using FLR. So now what are the possible questions, okay, from this concept? So one of the question number 1, suppose, so here is a question is given like this: the force developed by the conductors, okay, developed by conductor in the DC motor, okay, in the DC motor, the can be the direction of the, so this is a, just see here, this one is direction of the, question number 1 is a direction of the force developed by the conductor in the DC motor, the can be obtained by using, so by using dash. Options are given: the FLR, okay, option B FRR, okay, this FRR, and option C both, okay, and option D, so this is the none. So sometimes we have options like this. So now whatever it is given, suppose these two options are not correct, so this force direction is a required, the direction of the force is a required, so that this direction of the force can be obtained by using FLR only. Now same question, question number 2 is a given, so that is a direction of, okay, this the direction of the force developed by conductor, okay, conductor in the DC generators, okay, this is the DC generator, the can be obtained by using, so now this, what are the same options are given: option A the FLR, okay, option B FRR, okay, and the next one the new Faraday's law, okay, sometimes we have a question, Faraday's laws, and next one Lorentz force law, okay, force law, okay, these are the options. So now if options are given like this, we require direction of the force. So direction of the force, whether it is a generator or motor, but force direction that must be obtained by using which law? The FLR, okay, these are the two type of the questions, okay, got it? So very simple questions, but basic concepts are very important to know the other concept. So if we are good at the basic concept, then we can analyze the other basic concept. So other concepts in the DC machine. So what is the basic concept? What is the operating principle of the motor, and what is the force equation? Force is equal to BIL sin theta, and next one direction of the force in the DC motor can be obtained by using Fleming's left hand rule. What is the statement of the Fleming's left hand rule? So the Fleming's left hand means forefinger, center finger and thumb of the left hand are stretched in a perpendicular direction to each other. The forefinger indicates the flux, okay, then center finger indicates the current direction, then thumb indicates the force developed by the conductors, okay. So this was the discussion about operating principle of the DC motor. I hope you enjoyed this session. Thank you very much.